Now, we're going to have a quick revision on converting our decimal numbers to binary and our binary numbers to decimal. And we're going to start off with our binary to decimal. To start off with, let's get a number. So our number will be 0.00001011. And what does that equal in decimal? How do we work it out? Well, we're going to work it out using a place value. We're going to write down our place values, starting with our units on the right-hand side. So we're going to start off with the ones. And we're going to go 1 times 2 is 2, and 2 times 2 is 4, and 4 times 2 is 8, because this is binary, it's a base 2 number set, and 8 times 2 is 16, until we get to 128, and that's our 8 bits. Now we're going to take this number up here, and we're going to transfer it underneath those. So we're going to go 0, 0, 0, 0, 1, 0, 1, 1. Okay, now this is really simple. We're just going to say, well, there is no 128, so we'll cross that off. And there are no 64s, 0 64, so we'll cross that off. And there's 0 32s, no 32s, cross that off. And the same for 16. However, there is an 8. We've got a 1 in this column, so we've got an 8. So we're going to keep the 8. There's a 0 here, so we're going to cross off the 4. And there's a 2, so we're going to keep the 2. And there's the last one is a 1. So now it's very simple. All we're going to do is we're going to add our 8 plus 2 plus 1 equals 11. Therefore, we can say that 0.00001011 equals 11. Let's try and go the other way, decimal to binary. So again, we'll start off with a number. We'll start off with 27. And again, we'll work this out using our place value. And we'll just write our place values down again. 32, 64, 128. This time, we need to write our decimal number down because we're going the other way. So we're going to put it over here, 27. And we're going to have a look at our number 128 and say, does 128 go into 27? And the answer is no. So we're going to put a 0 here down the bottom of 128. And then we're going to say, does 64 go into 27? And again, it doesn't fit, so we're going to go 0. And 32 doesn't go into 27 either, so we're going to put a 0 there. Now 16, however, does fit into 27, so we'll put a 1 under our 16. Now we've used 16 out of this 27, so let's take the 16 away and get our new number. Our new number is 11. Let's cross this stuff off here so we know that we're just working with 11 and we're not confused. So now we're going to say 8. Does 8 go into 11? And 8 does go into 11. So we're going to put a 1 under the 8, and then we will take 8 away from 11 and give us 3, and then we're going to cross off those numbers. So we're working with 3 now. So now we go, does 4 fit into 3? And 4 does not fit into 3, so we'll put a 0 there. Does 2 fit into 3? And 2 does fit into 3, so we'll put a 1 there. And again, we will then go -2, and we'll get our next value is a 1. Right, we'll cross off those two. So we're working with our 1 now. We've only got 1 left, so does 1 go into 1? It does, so we should put a 1 underneath our 1. And if we keep following the way that we have been, we can go 1 minus 1 equals 0. Now, it should always end in a 0, so we can cross that off and give ourselves a big tick here because we did end in a 0, so we must have done it right. Now, we're going to take this digits that we've got here and we'll make a number down here. So we'll go 0.00111011. And now we can say that 27 equals 0.00111011. And that's our decimal to binary conversion. Now let's have a look at converting between binary and text. To do this, we're going to use this table called an ASCII table. So let's start off with having a look on converting binary to text. And here's our binary word down here that we're going to use. So we're going to look for this number in the table, 0.10000011. So the 0 1s are over here, 0.0011. So that's a C. So you see that there, that is a C on the table. So I'll put a C down. The next one is 011000001. We also look that up in the table, the 011 start in this column, and actually that turns out to be an A there. So we'll put our A down as well. And then the last one here is 01110100, and it is down there, so it is our T. So obviously it spells the word cat. Now let's have a look at doing it the other way, text to binary. So we used cat before, so why don't we just use dog now? Okay. We do it the opposite way. We just look up the D and we find there's the number that represents D. So we put that down underneath our D. And then we look up O in the table. And then we put the number that's next to our O down. And then we look up G in the table. And then we put the number that's next to G down. And there we go. We've now converted our binary to text and our text to binary using the ASCII table.